Hi geometry class, this is Mrs. Strickler, as you can see, videotaping from the privacy of my home. I hope you've had a good weekend. Well, we're going to try to get started here with our next lesson, even though you're not with me in class at ILA. So I hope by now that you've gotten the worksheet that I sent by email. It looks like this. I don't know if you can see that. 10.4. And it was sent in an email, and there will be another one for the next lesson as well. So I'm gonna get started. So why don't you take out a piece of paper, get your notes, and we are going to do lesson 10.4. Now after this you won't see me anymore because I'm gonna be projecting on the wall behind me, my living room wall, using the Surface Pro and the program that I have that I use at school. So let's get started. Okay, so here we are on the Surface Pro, getting ready to take notes. I hope you have your paper with you. So we're going to do 10.4, which is called Use Inscribed Angles and Polygons. So the first thing on your paper, it says the measure of an inscribed angle theorem. So what you're going to write down is the theorem, which says this. The measure, sorry about my handwriting, as we know it's hard on this surface to make it look pretty, but as long as you can read it, we're all good. Fortunately, I can't hear you right now. The measure of an inscribed angle is half the measure of the intercepted arc. Okay, I'm going to draw the picture. This picture is there for you. A, D, C is the middle, the center, and B. So what does this mean? This means on the second line straight across from there, I want you to write the measure of angle ADB equals half of arc AB. So you can finish writing that. I'm going to change colors for a moment because I want to highlight something. Okay, in this picture, an inscribed angle is angle ADB. Right there. It's got all of its endpoints. The vertex and the two endpoints are actually on the circle. And that measure is half of the arc. And the intercepted arc is the arc that's between the two endpoints. So AB is the intercepted arc for angle ADB. So for instance, if the measure of angle ADB was 100, then the arc would be 200 because it's half. All right, so let's do some examples. I'm going to switch colors. Example 1. And here's the picture. QRTS. And what's not on your picture is that this is 48 degrees and this is 50 degrees. So make sure you fill those in on your picture. And here we have point P, which is the center. Okay, so for number 1A, the measure of angle T. Okay, so T is right here. I'm going to highlight it a little. Right there. So the arc that corresponds to angle T, which is angle RTS, is going to be half of RS. So I'm going to write that angle T is half the measure of RS. So that is half of 48, which is 24. All right, so that's the first one. The next one is the measure of angle QR. So let's see, QR, that arc I'm going to highlight, darken, is up here. Now what do I need to know in order to find that? Okay, well, this angle here, I'm going to change colors so that we can see what we're looking at here. This angle here, we know this is 48, and I know that this angle is 50. So the corresponding arc to QRT is QT, and that's going to be twice as much, so that's 100. Now, it's not really clear in this picture because I didn't draw it very well. It's better on your note paper, but TPR is a diameter because it goes through the center P. So that means that arc TPR is 180. So that's this whole thing. This whole thing is 180. I went outside the 100. So QR would be 180 minus 100, which is 80 degrees. So you can see that when you have these intercepted arcs, you can find different pieces of the circle based on these theorems and other ones we've done before, like the fact that TPR is a diameter. That helps us a lot. And you would see that by the clues in the picture. So you have to look at the picture and see, TPR is a diameter, so I would be able to figure that out. So keep looking at the pictures in order to do that. Okay, so let's go on to the next example, which is example 2. And that says, find the measure of RS and the measure of angle STR. Okay, and here's my picture. And this says very small, that is 31. And we want to find the measure of arc RS. Okay, so I'm going to change colors again. I'm going to choose a different color this time. Okay, so RS is right here. And that corresponds with this intercepted arc. So if the angle is 31, then the arc is going to be 2 times that, which is 62. So that's the first one. And let's see, STR. Let's see, angle STR. STR, so this is 62. And I'm going to do a different color again. STR is here. So its corresponding arc would also be there. So STR and RUS share the same arc. So if SR is 62, this angle is also 31. So the measure of angle STR is 31 degrees. All right, and just to highlight that, the next question says, name 2 pairs, this is example 3. Name 2 pairs of congruent angles in number 2. So we're going to look up here at this picture up here. So we were just talking about this, and we're just going to name the angles. So angle STR is congruent to angle SUR, and then we're going to go on the other side. So we can say angle TSU is congruent to angle URT. So that's on this side. STU is the same as URT, and they share this arc right there. And my son is whistling as he comes up the stairs, and he's just gonna keep on going because I live in a house and we make noise. As I'm sure there's noise in the background for you. Okay, so go ahead and do the OYOs, and you can start on those. I'm just gonna copy them down, and you can pause the video right now. You can still be on pause. I am just copying the pictures and not talking while you work on these. And for number 2, you need to write a 38 there if it hasn't been fixed. And for number 3, find the measure of angle ZXW, and here's our picture. Okay, well, if you've unpaused your work, let's go over these OYOs. Oh, and this one is 90. You couldn't even do that one. So find the measure of this angle right here. So the measure of angle HGF equals half of arc HF. So that is 1/2 of 90, which equals 45. Okay, and number 2, we're going to find TV. So the measure of arc TV equals 2 times 38, which is 76 degrees. Okay, and you need this number here too, 72. I'm so sorry about that. I will look to fix those worksheets before I send them to you. Okay, so I'm looking for angle ZXW. ZXW, that shares arc ZW. So because the measure of angle ZYW is 72, then ZW, the arc there, is going to be half as much. No, it's going to be twice as much. Okay, yeah, so this is 144. So this is 144, but that's going to be the same as the angle that we want. So the measure of angle ZXW is also half, and that would be 72. All right, so let's keep moving on. Theorem 10.9. that says the measure of angle ABC equals 90 if and only if AC is a diameter of the circle. Okay, so you finish writing that down on the lines that are there, and I'll draw the picture. A, B, C. Okay. So what that says is, and what that means is that if AC is a diameter, then an inscribed angle like ABC that has AC as the hypotenuse will be 90. It's a right angle. So that is 90. Okay, so let's turn the page and look at the problem there. And it says, with the picture, your camera has a 90-degree field of vision and you want to photograph the front of a statue. So do you see in a picture statue, see a picture, there's a statue from above and there's a camera set up. So you move to a spot where the statue is the only thing captured in your picture as shown. You want to change your position. Where else can you stand so that the statue is perfectly framed in this way? Okay, well, right to the right of your photo there, I'm going to draw a picture of what we have. So looking down, here's the statue. Don't you love my art? I'm so good, aren't I? I never claimed to be an artist, only a math teacher. And you guys are nice and patient to put up with my drawings, so there you go. All right, so the first angle that we have of the scope is 90 degrees, and that will get the whole statue looking on here from the front to take a picture. So where else can we put the camera? Well, we can have a different shaped triangle. So we could have one that's like this. We could have one that is longer over here. It still has the open position so it can get the whole statue. And if you lined up all the possibilities, they would all be along this semicircle. Do you see that there? So you can say that the statue fits perfectly anywhere within your camera's 90-degree field of vision from any point on the semicircle. Okay, so that is example number 4. I'm going to switch colors again. And we're going to do theorem 10, 10. And you're going to write in the blank a quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. Okay, so write all of that on the line, 2 lines provided. I took 3. And while you finish that, I will draw the picture. So E, F, D, G, and this is point C. And what that means is I want you to write this below D, E, F, and G lie on circle C if and only if the measure of angle D plus the measure of angle F equals the measure of angle E plus the measure of angle G, and they all equal 180. So they're supplementary. So D and F are supplementary. They add up to 180. And E and G are also supplementary. Those are opposite angles. So that's what it means. And just so that we know our definitions, inscribed mean this is a polygon. We say a polygon is inscribed if all its vertices lie on the circle. And a circumscribed circle, we say the circle that contains the vertices is a circumscribed circle. Okay, so go ahead and write all that down. While you're doing that, I will draw the pictures. So example 5. A. This is 80. This is 75. This is Y and this is X. And then B. This is 2A and 2A. And this is 4B and 2B. There may be a mistake on there, so please change that. Sorry, these are supposed to reach the corners. Okay. All right. Gonna change colors again. I hope you're caught up. If ever you get behind, feel free to pause the video and get caught up. Do this at your own pace. Okay, so we've got opposite angles are supplementary. So that means that angle P and angle R are supplementary, so they add up to 180. And angle P is 75 and R is Y. Boy, that's pretty easy, isn't it? Don't you love it when they're easy? And I get Y equals 105. And the other one, Q and S. So the measure of angle Q plus the measure of angle S is 180. So Q is 80, S was X, sorry. So we subtract 80 and X equals 100. Nice and easy. Okay, it's a little harder, but really still not that hard. So angle L and angle J are supplementary. So I'm going to write the measure of L plus the measure of J equals 180. And L is 2A and J is 2A. So I get 4A divided by 4. A is 45 degrees. I wrote that kind of fast, so feel free to pause it if you need to. But I'm going to continue on. So here's this angle, K and M. They're opposites and supplementary. So I would say the measure of angle K plus the measure of angle M equals 180. So 4B plus 2B equals 180. So now I have a simple algebra problem like I did in the one before. So 4 plus 2 is 6. Divide by 6. B equals 30 degrees. Okay, so I'm going to be drawing these pictures. You feel free to go ahead and start working on the OYOs, and I'm sure by the time I'm writing them, I'm going to move this over a bit, we'll be caught up. Find the variables. Number 1. A, B, C, D. This is X, Y, 68, 82. And number 2. This is C, and this is 2c minus 6, and this is 10x, and this is 8x. Okay. All right. So you work on those for just a moment. All right, okay, so let's do these together. I'm going to change the color again. Let's do something else. So our opposite angles are supplementary. So x plus 82 equals 180. Very simply subtract 82, not 182, and x is 98. And then these angles. So I have 68 plus y equals 180. And I get y equals 112. And then the other one, opposite angles are congruent. So I have 8x plus 10x equals 180. 18x equals 180. X is 10. And that's degrees. C plus 2c minus 6 equals 180. Those are opposites. So let's combine 2 and 3, or 2 and 1. Add 6 to both sides. 3c equals 186. Divide by 3. And c is 62. Okay, that is the conclusion of our first lesson, and your homework for lesson 10.4 is on page 676 to 678, and that is number 1 through 19 odds and 27, and that's all. So you feel free to pause it, and I'm going to start on the next lesson when you're ready. Okay, so here we are continuing on lesson 10.5. Here we go. We'll start in purple this time. This lesson is called Apply Other Angle Relationships in Circles. There's a lot of theorems here, so that's why on your sheet my pictures are so tiny. Sorry about that. I'll try to make them bigger on the overhead. But I'm sure there's enough room to fit everything in because we've done it before. Okay, so let's start with theorem 1011. So this is 1011. And you can write down, if a tangent and a chord intersect at a point on the circle, then the measure of each angle formed is half of the intersected arc. All right. You finish writing that, and I will draw the picture that's over to the right, and you can look at yours in just a moment. That's not good. Okay. This is angle 2 and 1, and this is point A and point B. Okay. So what this means, the measure of each angle formed is half the intercepted arc. So you can see you have a tangent, that's that line right there, and you have a chord. You have chord AB in the circle right here. So they intersect at a point on the circle, and what does that mean? The measure of each angle formed is half of the intercepted arc. Okay, I'm going to change colors for just a second again. I want to get this. So let's look at the measure of angle 1. That means that the measure of angle 1 is half of this arc right here. There's angle 1, and it's half of that arc. So if I knew that arc, the measure of the angle would be half of it. In the same way, let's look over here at angle 2. This is angle, I'm going to mark this angle here. Angle 1 is right there. Now I'm going to change colors so we can see it. Okay, so the measure of angle 2 is right here. It comes down the chord, intersects at the circle and the tangent, and then goes out the tangent, just like that. So that arc is right there. So the measure of angle 2 would be half the measure of, let's see, oh, I'm missing a point C here, of arc ACB, like that. Okay, so let's do some examples. I'm going to change colors back to purple since we were working with purple. And I'm going to draw a picture a little bigger for you. This is 130, if you can read that. And this is AB. So in the first one, I'm going to try to find the measure of angle 1. So my arc here is 130, and 1 is the angle, so that is this angle right here. Like this. Doesn't look very accurate, but it is what it is. So that would be half of 130. We believe numbers, not pictures. Okay, so that is 65. Let's do another one. I'm running out of a little room there, so you go ahead and just follow the picture. Look at B. Find the measure of KJL. and that is right here. Looks like this. It's very tiny, and it's got a circle on it like this, and this is KL, and this is point J, and funny looking J there. This is 125. That might be hard for you to read. So we want to find the measure of arc JKL. Again, I'm going to switch colors. Okay. So I want to find this arc. The angle here is from the chord to the tangent, and my arc is KJL. So I'm going to take my angle measure. This would be the measure of angle L is 125, and I'm going to multiply it by 2, and I get 250. So the measure of the arc is 250 out here. Okay, so you guys go ahead and do the OIOs. There are 3 of them there. While you're working on them, I will draw the pictures and then we'll go over them. So here's the OIOs. I'm going to draw them a little bigger for you. Find the measure of angle 1. And it looks like this. Number 2, actually it doesn't have a circle on it. And this says 98 here. And this is TSR. Number 3, find the measure of arc XY. And you can't see that very well, so write that in as 80 degrees. Okay, we're going to go over these. I'm going to change colors. All right, the first one, the measure of angle 1 is right here, is going to be half of my arc. So it's going to be half of 210, which is 105. So that whole thing is 210. Okay, number 2, I have the angle, so this is 98, so I'm trying to find the arc there of RST. So that's going to be 2 times 98, which is 196. And the last one, I'm going to find the measure of XY. It's an arc right there. And that is going to be 2 times 80, which is 160. Okay, so let's keep going on. Hopefully you understand that well. I'm planning to have tutoring on Thursday or Friday this week. I will let you know. And if you have any questions, we can answer them then. So let's keep going on. Theorem 1012 says if it's about 2 chords intersecting inside the circle. So inside. So here's my picture. You already have this. A, B, C, D. And this is angle 1 and angle 2. Okay. So this theorem tells us that the measure of angle 1, which is right here, is half of the measure of arc DC plus arc AB. Okay? So angle 1 is going to be half of this arc plus this arc. So you see the position? Here's one angle in here, and then it's half of its corresponding arc plus the one on the other side. Okay, the other part of the theorem is the measure of angle 2, which is right here, equals half of the measure of arc AD plus the measure of arc BC. So let's look at that. That's going to be angle 2, its corresponding arc plus the opposite one. So angle 2 is half of this arc plus this one. It's a sum. Do you see that down below? We're adding. And we use this to find angle measures using arcs. Okay, this is where it gets a little bit harder, but it really isn't bad if you can just keep track of the details. So this time we have two segments intersecting outside the circle. So the last one, we had two segments completely inside the circle. And we can have two segments intersecting in three different positions. So you've got three pictures there. So each one is a different scenario. You have one segment cutting through the circle, and the other one is tangent. So that's AB. This is angle 1, and this is C. Okay, that's the first situation. Then we have, here's our circle, and we have both segments tangent this time. Whereas the last time we just had one. Over here we had one tangent line, and this goes through as a secant. Here we have two tangents, and the third situation is when we have a circle and both segments cut through the circle. So we have one cutting through, none cutting through, but tangent, and then both cutting through. So this is WX with 3, Z, and Y. So those are our three situations, and each time we have a different formula depending on the picture. So really all you have to do is look at the picture and see, do I have this situation, this one, or this one? What does my picture look like? And once you find that, then you're going to use the corresponding theorems and formulas, which we don't have written down yet, but that's basically what you do, okay? So it will all be obvious and clear very soon. So the measure of angle 1 is going to be equal to half of the measure of arc BC minus the arc of AC. Okay, so that would be BC, this here, minus AC. So the measure of the angle is half, like in the last one, of the big one minus the little one. Okay? Now the second situation, when we have tangents, we're going to have the measure of angle 2 equals half of the measure of arc PQR minus the measure of arc PR. So this 2 is going to be half of PQR, this one, the big one, minus this little one. So we're doing another minus here. And then for the measure of angle 3. They're all minuses and very similar situations. You just have to keep them straight. So the measure of angle 3 is half of the measure of arc XY minus the measure of arc WZ. So we're going to have angle 3 is going to be half of the big arc minus the little arc. And all of these are a difference. When you have the segments outside the circle, we subtract. When we have the segments inside, we do what? We add. Okay, so let's go down to the first example. Sorry, a little bit all over here. Okay, example number 2. Here's the picture. And the only thing they give us is this out here. All right, so let's look at it. Which situation do I have? I have both segments completely inside. So it's going to be theorem 10.12 because both segments are inside, and it's going to be the sum. So I'm going to have x, the measure of angle x, well, let's just leave it at x, equals half of, oh, and this is 138 over here, half of 156 plus 138. So you see they're both inside, so it's half of this plus this. So all I have to do is combine those. I get 294, and half of 294 is 47. So the measure of angle x is 147. All right. So let's go to the next example, number 3. I will leave that there so you can finish writing. And I will draw the picture. C, D, B, this is 76, and this is 178, and this is A. Okay, so look at the situation. What have I got? I've got one segment is a tangent, and one segment cuts through twice on the circle. It's a secant. So I'm going to look up here. What is that situation? That is this one, right here. So I'm going to use that formula. So let's write it down. So I'm going to say the measure of angle x, which is inside here, really tiny in there, is going to be equal to half of what? AD, this segment here, minus BD, right there. So I'm going to have half of the measure of arc AD minus arc BD. So this one here minus that one. So now I just put my numbers in. Half of AD is 178 and BD is 76. So the first thing I do is subtract, and I get 102. And then I divide by 2 and I get 51. So the measure of angle x is 51 degrees. Okay, so you guys go ahead and start working on the OIOs while I write them down. Find the variable. Let me see your picture. Something isn't right about this. Okay, this actually should look like this. I am so sorry. I will try to fix this on your paper. It should be A, B, C, D. And this is 102. And this is Y here. And this is 95. Like that. Okay, it should look like that. So let me change colors and we can get to work. Okay. All right, number 1. This is the situation where both segments are completely inside the circle. So we are going to have a sum. So the measure of angle X equals half of 63 plus 89, which is half of 152. Did you get that? And that is 76 right there. Okay, now the second situation is we have two lines cutting across in two places. So I'm going to have this angle, and this is what I'm trying to find, A here, and I know this is 44, and this angle here is 30. I didn't write that down. Okay. So the measure of angle J is going to be half of the measure of arc FG minus arc KH. So I know that angle J is 30. And I don't know arc FG, so that's A minus KH is 44. So once I can put those numbers and letters in the correct place, I just solve them like a regular algebra problem. So let's do that. I'm going to distribute the 1/2, and half of 44 is 22. And I'm going to keep solving for A. So I'm going to add 22. And I get 1/2 A equals 52. I multiply by 2 on both sides, and I get A equals 104. All right. Now I'm going to do the last one. So again, this situation is like number 1 on OIOs. So I'm going to have, I have a problem though. This goes through the middle here, and I need this angle, don't I? I need something there in order to solve for Y. Because what I know is that if I have this angle, it's going to be half of 95 plus Y. How can I figure that out? Well, I have a diameter here, so that means that BCD, arc BCD is 180, so that, and it's degrees actually. It's not, I'm not going to look at that. I'm going to look at the, sorry, I'm going to look at the angle. A straight angle is 180. So this little piece is going to be 180 minus 102, which is 78. So this here is 78. Now I have all the pieces I need to solve it. So I'm going to, my formula says, what? Let's go up here. Right here it says this. So I'm going to look at that again. My formula says that the measure of angle 1 equals half of DC plus the measure of arc AB. So it's a plus. but I have this angle, so I'm going to put 78 here, and I get half of DC, which is 95, and I don't know AB. That's my Y. All right, so I've got 78 equals, I'm going to distribute the 1/2, so I have 47.5, and then 1/2 Y. So let's subtract. 1/2 Y equals, and when I subtract, I get 30.5 degrees. Now I multiply by 2 on both sides, and I get Y equals 61. That's a tough one, so you might want to pause this, rewind it, and go back and look at that again. And if you still don't get it, I would be happy to help you at tutoring on Thursday. Okay, so let's go on to example 4. Let me draw the picture. If you want to look in your book, it's example 4 on page 682. So above the earth, here is example 4. Northern lights flash at 150 miles above the earth. What is BD? That's an arc, the portion of the earth from which it is visible. So this is interesting. If you've got northern lights going, how much of the earth, the surface of the earth, can see them if they're 150 miles up? So I'm going to draw the picture. By the way, the circle is the earth, and C is where the lights are going off. So this little portion, if you can write it in okay, this right here, this part is 150 miles. And my radius from the interior of the earth out is 4,000. Okay, so that means this is 4,000. It's a radius also. And then CA, this whole thing here, is 4,150, which is the radius plus the distance above the earth to the northern lights. Okay. So in order to find the arc of BD, I need to find the measure of angle BCD. So we're going to talk about that. So your first thing you want to do is you want to write down, I need the measure of angle BCD to find BD, that arc, okay? And look what I have here. I have two triangles. If I have triangles, let's see what kind they are. Well, this creates here a tangent and a radius coming out from the middle. This becomes a right angle. So if I have right angles, I have right triangles, I can use trig functions. To get angle measurements. Okay? All right, so I can say, number one, that CB and CD, right here, this line here, and CD here, are tangents. Then the measure of angle B and the measure of angle D are right angles because of that theorem that says that tangents are perpendicular to the radius of the circle at the point of tangency. Okay, so if I have, now let's talk about, I need to know what this angle is. I need to know these angles in here. These little angles. I'm going to change colors so we can see. I need to get this whole angle, BCD. And then in order to do that, I need those two parts. Well, if I have congruent triangles, then I have congruent parts. So let's talk about two congruent triangles first. So let's start there. Do I have congruent triangles? Triangles BCA, is that congruent to triangle DCA? Is that true? Well, let's look at the sides and angles. BC is congruent to CD because of they are, C is the common point there, and they're both tangent to the circle, so I know that. I know that CA is congruent to itself because of reflexive. So I can say that the triangles are congruent by hypotenuse leg. Okay? Because I have a right triangle. All right. And then I can say that angle BCA is congruent to angle DCA because of congruent parts, right? So now I know my angles here are the same. So I've got congruent triangles, so let's find the measure of angle X. Hang on. So I'm going to solve for angle BCA. I want to find the measure of BCA. So look at the picture. If I know that I have this angle here, and I have this is 4,000, and this is 4150, from here it's opposite over hypotenuse. That is the sine function. So I'm going to say this is X. And then I'm going to say the sine of X is the opposite over the hypotenuse. But to find the angle measure, I use the inverse function. So when I figure that out, using inverse, I get 74.5 degrees. Then, this is a long problem, hang with me, I know it's long. If half of this big angle CBD is 74.5, then the whole thing, BCD, is 2 times that, which is 149. So, using the theorems that I've learned so far, the measure of angle BCD equals half the measure of arc DEB minus the measure of arc DB. All right, and the measure of arc DEB is going to be 360 minus x, and the measure of arc DB is going to be x. And I know BCD, this is 149. So now I'm going to substitute this in here, and I get 360 minus x again, and this will work out to be my answer. So I have 149 equals 1/2 of 360 minus 2x. Now I'm going to distribute. So I have 180 minus x, and when I subtract and switch, I get negative 31 equals negative x, and x equals 31 degrees. Okay, so the arc of the Earth is 31 degrees. That's the amount of the arc, that is arc BD, that can witness the northern lights. Are you still with me? That was long and hard. If you got lost somewhere, please pause the video now, stop it, and go back and listen again and see if you can follow along. And if you're having trouble with this problem again, please come to tutoring on Thursday or Friday. Okay, so our homework for this section is 683 to 684, number 1 through 13 odds, 22, 23, and 25. Okay, we are done with our first videotape. I think you guys did great, and I hope you understand everything, and we will be in touch again soon. Have a great day. Bye now. I'm going to go turn it off.